Hello everyone, my name is Abhinay. I'll be presenting our work titled Overcoming Black-box Attack Inefficiency with Hybrid and Dynamic Select Algorithms, which I worked on with Rohit Ramkumar and Professor Jonathan Russert at Purdue University Fort Wayne. The focus of this work is adversarial text attacks in a black box setting and how we can make these attacks more query efficient without losing effectiveness. So as models grow with more complexity, adversarial testing becomes computationally expensive, often requiring hundreds of queries. So in this talk, I will explain existing challenges, introduce our two methods, which are the hybrid select and dynamic select, and present experiment results across multiple datasets and models. So to begin with background, so what are black box word level attacks? They are black box in general means that when a model is queried, we get back probabilities and the prediction that the model gives us, and we do not know any of their internals such as weights. Typically, the attack has two main steps. First is the selection and the modification. When it comes to selection method, our goal is to find the most influential word in the input. After which, when we find the influential word, we do the modification where we try to replace that word to see how the model's decision is altered. Our goal in doing this is to mislead the classifier with minimal changes while preserving the meaning. So here what happens is the main challenge is to maintain the queries. So in order to not blow up the query numbers, uh, we decided to introduce two new algorithms which maintains query efficiency by having the minimal perturbations. We consider four baselines, which is the greedy select, binary select, and PWWS and clear. So greedy select is something that removes word by word and sees which word causes the largest drop in the model's confidence. Greedy select is good. It's very strong and has high success, but it is very query intensive. And when it comes to binary select, what it does is it splits each text or each example into two halves and sees how the model causes the biggest drop. So it does this iteratively until it reaches a single word and then determines that it is a influential word, upon which it goes for the replacement step. PWWS and the Claire methods are almost similar, so we extend our algorithms uh, built upon this. So we generalize the binary select, which is called as the n-ary selection. So in binary select, n is set to 2, and we extended this algorithm by making it generalized by keeping the n value to any arbitrary numbers. We stick to numbers such as 3, 4, 6, and so on. We ablated studies on 12, 24, and 36 as well. So what happens in n-ary select is that we test each segment by splitting with the number n. Suppose for 3 we split the text into 3 equal parts and see which segment is most influential by removing it to see which has the largest drop. We recursively do this until we reach a single word to see which word is most influential. But this is again like binary select where the attack could possibly lose context, and the drawback is that we could there is a chance that we excluded the most critical word in few of the segments. So we went on ahead and created an algorithm called hybrid method, and I'll also introduce about dynamic selection as well. So what happens in hybrid select is that we start off with the n-ary select itself, and then suppose in this instance we have n equals to 3, where the text gets split into 3 segments. So we introduced a hyperparameter called text threshold or segment threshold. We kept the threshold percentage as 10% in most of our experiments. We also ablated on percentages on threshold percentages such as 20%, 25%, and and we found that most attacks were successful and showed more efficiency when we consider 10% threshold. So what happens here is that during n-ary select, it goes down until three until a segment where until it reaches 10% length of the entire example. Once that segment is identified as the most important, it goes to the greedy select and tries to understand which word is influential by removing each word. So there's another special case about this hybrid algorithm where we do sentence level. So in sentence level hybrid algorithm, we consider each sentence itself as as an element, after which we try to do an n-ary split. And then the same thing goes on iteratively until each segment gets identified and being sent to greedy select for identifying which is the most influential word. And then the replacement as well goes on. So we added another method called dynamic n, where sometimes we thought that instead of hard coding n equals to 3 or 2, we decided to use a validation dataset for the target dataset such as IMDb or Yelp or AG News. We suppose we are attacking on IMDb, we run a validation, we run this n-ary on the validation dataset to understand which n is the most optimal value for different lengths. So it learns how for which length of the sentence n is more optimized. So during the attack, instead of setting the n to instead of fixing the n value to some number, the algorithm chooses by itself using these length bins. So we also, when it comes to replacement, we use two basic replacement methods, which is the word net replacement and bird replacement. In most of the experiments we stick to word net replacement, as we do not see much improvements or much use when it comes to bird replace or word net replace. It's equal in performance, so we stuck on to using word net itself. When it comes to models and datasets, we used about 4 datasets, which is IMDb, AG News, Rotten Tomatoes, and Yelp reviews. And we performed experiments using the target models such as Distilbert, Deberta, GPT-2, GPT-Neo, and Llama 3, and T5. So these are 4 LLMs and 2 encoder-based models. So these are the key results. We compare between the baselines and the best methods. So the here the values are all averaged out. So here the baselines, on an average, they produce 425 queries for the IMDb, being the longest sequence of sentence words in the sentence or the example. So it yielded about 425 queries, but our hybrid version, which is the best version, best variant, yielded about 362 queries. Same drop in percentages are observed throughout the datasets, where we see about a 15 to 20% reduction in queries. So here the conclusion is that hybrid select does efficiently combine coarse-grained n-ary and fine-grained greedy search to achieve greedy level attack success with far fewer queries. And dynamic select also helps us attack the example by adaptively choosing which end to choose, and this is a very good optimal selection strategy on the fly. And on an average, we have seen about 25% reduction in model queries. And future works could include such as improving selection methods for more advanced diverse word replacement strategies. And there's also some room for improvement for dynamic criteria to make to select n on fly instead of training it separately. So our main theme is to make adversarial attacks more faster and more scalable without compromising their effectiveness. And this paper takes a big step in that direction. Thank you.